I recently read Algorithms to Live by Brian Christian and Tom Griffiths. One day, you'll need to hire someone, if you haven't done so already. You may hire a freelancer online to help you with your next business project. You may hire a new team member at work. Or you may hire someone to clean your house or look after your kids for a few hours a week. Regardless of what you're hiring for, hiring is stressful. But hiring can be a lot less stressful if you can rely on a set of algorithms formulated by mathematicians and computer scientists. Algorithms are a finite sequence of steps used to solve problems and make decisions, and they're the backbone of digital products. The computer or smartphone you're using right now relies on algorithms to determine which programs to run, when to terminate a program, how to sort incoming data, and how to communicate with other computers. There are 3 computer algorithms that we can apply to hiring to efficiently solve the following 3 problems. First, among a group of qualified candidates, who should I hire? Second, how should I go about onboarding my new hire? And third, when should I move on and try someone new? To solve problem number 1, you need the selecting algorithm. There are 2 ways to fail when selecting a candidate for a position. Decide too early and miss out on better candidates, or decide too late and miss your chance to hire the best candidate. Let's pretend you have a group of 20 qualified candidates for a position you're trying to fill. You don't want to be rash and take the first person you interview, but you also don't want to spend hours interviewing all 20. Luckily, there's a third option, a mathematically proven algorithm called the 37% rule. The 37% rule states that you should evaluate 37% of your options with no intention of selecting. That is, reject the first 37% unconditionally. Then after evaluating the first 37%, pick the next option you encounter that's better than all the options you've sampled. So in the hypothetical situation of choosing between 20 qualified candidates, you should interview the first 7 candidates with zero intention of hiring any of them. Then continue interviewing the remaining 13 and stop the instant you find a person who is better than any of the 7 you initially interviewed. The power of this method is it gives you a chance to determine your preference, and it gives you a good benchmark for which to base your final decision on. Several years ago, a graduate student named Michael Trick used the 37% rule to select his future bride. He determined that he'd date between the ages of 18 and 40. So based on the 37% rule, when he turned 26.1 years old, he should ask the first woman, who is better than all the other girls he's dated, to marry him. When he met that woman shortly after the age of 26, he said there was no doubt that she met the qualifications for this step of the algorithm. So I proposed, and she turned me down. The 37% rule isn't guaranteed to get you the result you want, as Trick discovered. It just gives you the best chance, the highest probability, of getting the best outcome. Now, it's important to note that the 37% rule is only valid if you cannot return to previous options. Now, this is typically the case when dating, but maybe not when hiring. If you believe that there's, at a minimum, a 50% chance that past candidates will still accept your offer, that is, they didn't move on while you were sampling, or they didn't lose interest in your offer, then the 37% rule turns into the 61% rule. That means if you're looking for the best possible candidate, you should hold off hiring until you interview at least 12 candidates. Then if you don't find a better candidate in the remaining 8 people, then you can go back and pick the best person you interviewed of all 20. The next algorithm worth knowing is what I'll call the onboarding algorithm. When you bring a new hire on board, it's hard to know how much work you should give them. You want to maximize their skills, but you don't want to give them so much work that they make mistakes, fail to meet your standards, and create a mess you need to clean up. For years, computer scientists struggled with a similar problem. When a computer connected to a network of computers, that computer would get bogged down with requests and fail to deliver information back to the computer that was requesting the information. To fix this problem, computer scientists came up with an ingenious solution known as the Transmission Control Protocol, TCP. When a new computer joins a TCP network, it starts receiving a single packet of information from a sender and lets the sender know it's received the packet by sending an acknowledge packet. With each acknowledgement, the sender doubles the number of packets it sends. But the moment the computer gets bogged down with too many packets and fails to send an acknowledged packet back to the sender, an algorithm called additive increase multiplicative decrease, AIMD, kicks in. The AIMD algorithm reduces the number of packets being sent by half. This drastic cut frees up space on the network and allows the receiving computer to catch up. If after this reduction, the receiving computer accepts a reduced packet load, the sender will be allowed to add one additional packet to each future message. The authors say, AIMD takes the form of someone saying, a little more, a little more, a little more, whoa, too much, cut way back. Okay, a little more, a little more. You can use a similar algorithm to ensure the success of a new hire. Let's say you hire a freelancer and you give them a tiny task. After they return that work, on time and on spec, you double the workload, and you keep doubling until you get back work you're not satisfied with. At that point, you immediately cut the workload by half. With this exponential growth in work, you can quickly find the freelancer's capacity. Then by only increasing their workload by 1 unit at a time, you give them a chance to build back up slowly so that when they reach the level they failed at, they'll have far more confidence and will be far more likely to succeed. The next algorithm worth knowing is what I'll call the switching algorithm. If a freelancer or new hire is consistently meeting your expectations, then you don't need to think about replacing that hire. But if they're only meeting your expectations half the time, you'll want to explore new options using the Gittins Index. In the 1970s, a young mathematician named John Gittins was tasked with optimizing Unilever's pharmaceutical investments. Gittins had to determine if Unilever should continue investing in a proven drug or pivot to a new drug on trial. Based on several iterations and months of calculations, Gittins came up with a table of values to help Unilever determine if they should pivot to a new drug they believed would be at least 90% as effective and profitable as a proven drug. Unilever used this table by determining the success and failure record of 2 drugs, by calculating how often those drugs were or were not successful at treating a disease, then used Gittins' table to find the corresponding Gittins Index. The drug with the highest Gittins Index was deemed the best option to pursue. Gittins indexes are now regarded as a mathematically reliable method to determine if one should pivot or persevere. You can use the Gittins Index to determine if you should continue investing in a project or a person you've just hired. Once you determine the success and failure ratio of your current option and an option with 90% of the expected value of your current option, you use the Gittins Index table to determine which option has the highest value and go with that option. Now, you need not consult the Gittins Index table for every decision. You only need to remember these 2 key findings. First, an untested option with a success-failure record of 0 and 0 has a Gittins Index of 0.7. This means if a project or person is not meeting your expectations at least 70% of the time, that is, they have a success rate that's lower than 70%, you should consider switching to a new project or a new person if you believe a new project or person has similar potential. Second, if you go with a new option and their early success to failure ratio is worse than your current option, it still might be a better option. For example, if a new candidate has 3 successes and 4 failures, that is, they've met your expectations 3 times and haven't met your expectations 4 times, they will have a higher Gittins Index than a veteran who has 1,000 successes and 1,000 failures. The authors say, the untested rookie is worth more, early in the season anyway, than the veteran of seemingly equal ability, precisely because we know less about him. Exploration in itself has value, since trying new things increases our chances of finding the best. In the end, take the stress out of your decisions by trusting mathematically validated algorithms. The next time you're struggling to select a candidate, remember the 37% rule. Determine your sample size, or sample duration, and use 37% of your sample size, or sample time, to generate a benchmark. Then select the next best option that comes your way. Remember the transmission control protocol and the AIMD algorithm. Start small, keep doubling up, then reduce by half when you encounter a failure, then gradually build back up bit by bit. And lastly, remember this key finding of the Gittins Index. When you have two comparable options, go with the newer, less tested option for higher potential reward. That was the core message that I gathered from Algorithms to Live by Brian Christian and Tom Griffiths. This book brings a fresh perspective to decision making. I highly recommend it. If you would like a one-page PDF summary of insights that I gathered from this book, just click the link below and I'd be happy to email it to you. If you already subscribe to the free Productivity Game email newsletter, this PDF is sitting in your inbox. If you like this video, please share it. And as always, thanks for watching and have yourself a productive week.